Okay, boys. Okay, index laws. Now, gentlemen. Okay, just slow down, people. Okay, index laws. Hopefully, guys, this should be something that you're comfortable with. Okay, we've done index laws for a long time now. I know in grade 9 they do it. I know you did it last year. So most of this will be revision. Okay, so just a quick review of what an index is. So it's made up of a few things. Okay, so if I had 4x cubed, the number that's out front is called a coefficient. Okay, now the bottom of the index is called the base, and then that number that's raised up has a bunch of different names. You can call it an index, you can call it a power, or you can call it an exponent. You'll hear interchanged. Now, this is just an efficient way of writing repeated multiplication. So x cubed means x times x times x. Okay, and the 4 just means we multiply x times x times x by 4. Okay, so let's continue. We have 8 index laws that you guys should be familiar with. The first index law is the simplest, obviously. And guys, if I have a to the m, okay, and I multiply it by a to the n, we are going to have what? A to the m plus n. So, if I had x squared times x to the 5, it would be x to the 7. Okay, the second one, if I have a to the m divided by a to the n. Now guys, I don't want you to jump the gun. I can write this in a different form. What's another way I could write this? A to the m over a to the n. And guys, both of these evaluate as a to the m minus n. Okay, are these coming back to you? Okay, good. Now, third one. If I have a to the m and I raise it to the power of n, this equals a to the m times n. It's a to the m times n. So if I have x squared cubed, that's going to give me x to the 6. Okay? Now guys, you can always break this down into other, if you forget an index law or something, and you had x squared cubed, well, you would know that that just means x squared times x squared times x squared. That's all that means. So that's just x to the 6. Okay? So if you ever run into trouble, you can always break it down into other things. Okay, the fourth one. Okay, if I have a times b, all to the power of m, I have to distribute the power through. So guys, this is a to the m, b to the m. Both get the power. Fifth index law. If I have b over a and I raise that to the power of m, I also have to distribute the power. So that becomes b to the m over a to the m. Okay. The sixth index law is when we start having negative indexes. Now, boys, I could write this as a fraction. Sam, stay with us, please. I can write anything as a fraction. I can put that over 1. Now, gentlemen. No, it's still negative m. It's over 1. Now, gentlemen, I can move terms with powers up and down, a fraction. If I move my term with the power, like up or down the fraction, what do I have to do with the power? I have to change its sign, right? So this is actually the same as 1 over a to the m. And I can go the other way, too. If I had 1 over a to the negative m, that would just be a to the m over 1. Because I moved the term with the index up, and that changes its sign, and that makes it a positive m on the top of the fraction. But guys, do I need to write over 1? No, I can just write it as a to the m. Okay. And then there's the 8th index law. Okay, which is a over b. I don't know why it's a over b and not b over a, or the other one's the other way around, but anyway. Now guys, how can I rewrite that? B over a to the m. Now the reason I can do that, guys, is if I distribute that negative m through, it would be a to the negative m over b to the negative m. Then we can just swap the two, because we can move them the one up and the one down. They both become positives. And I can take that m out. I can factor that m out. Yes, Luca? We'll do that tomorrow. That's a rational index. Yeah, guys, we're doing rational indexes tomorrow. You know what? Let's write that down. Guys, put this down. Just remember, guys, a to the power of 0 equals what? 1. Okay, that wasn't on my list, but that's a good one to have. And I don't know if it comes up tomorrow or not. A to the 0 is just 1. Anything to the power of 0 is 1. Okay, so guys, let's do some examples. Okay, so, guys, if I have a squared times a to the 6, that's just x to the 8. Now, guys, you don't have to write 2 plus 6. You don't have to do this in 2 steps. You can do it in 1 step. Now, let's look at 1b. Now, guys, this is important because you can't forget about the numbers. Okay, I'm multiplying the numbers together. So the number out in front is now going to be 15. Now, guys, what index goes with the a in the 3ab cubed term? Now, what goes with the a? What index, what power does it have? 1. So that's a to the power of 1. Okay? So there's really a power, that a has a power of 1. So, when I multiply the a's together, it's a to the 1 times a squared, and that's a to the 3. And it's b to the 7. Now, boys, you don't need to write this down. But if it helps you to visualize, all of this is really just 3 times a times b cubed times 5 times a squared times b to the 4. Okay? And you can, with multiplication, you can move terms anywhere you want. So I could rewrite that as 3 times 5 times a squared times b cubed times b to the 4, and then simplify it if I really wanted to. Okay, but we have rules, like shortcut rules to help us. Okay, the next one. Yep. Yes, well, if you want to miss this is good stuff. Guys, what am I doing for 2a? What am I doing with the indexes? Yeah, subtracting or minusing. X to the 3. Okay, now boys, on the next one, when they're in fraction form, What technique can we take advantage of? Simplifying. Yep, that's right. Or just canceling. Guys, tell me what happens to the x squareds. They cancel. Because anything divided by itself is 1. Anything times 1 is itself. Okay. Can I cancel anything from the 10 and 15? Yeah, 5 goes into both of them. Okay, 5 goes into 10 twice. 5 goes into 15 3 times. Now guys, how I show this next one is, we have y to the 7 and y cubed. Obviously the 7 is bigger than the 3. So I'm going to subtract the smaller number from the bigger number. So the y cubed is going to cancel with the, and make that 7a 4. So what we're left with is 2y to the 4 over 3. Is this coming back to you, boys? Very good. Now, with this next one, boys, we just need to be following along. Noah, come on, mate. Alrighty. With this next one, guys, we need to remember, we need to distribute that squared to every single, not really term, but part of that term. So I have to distribute that squared to the 3 as well. So I have to give that squared to the 3. So this is 9. 3 squared is 9. You must distribute the squared to every part of that term. Okay? Now, that x, so we had to square x to the 4, and that becomes x to the 8. I have to apply the squared to to y cubed, and that becomes y to the 6. Now guys, again, you don't need to write this down, but this here is the exact same as 3x to the 4 y cubed times 3x to the 4 y cubed. So really, I'm multiplying 3 to 3, x to the 4 times x to the 4, y cubed times y cubed. Right? And if I did it that way, that's 9, x to the 8, y to the 6. So that's why we have to give that squared to every single part of the term. Does that make sense? Okay, let's look at the next one. So, same thing, guys. I have to give this cubed to every single part of the term on the top and every single part on the term on the bottom. So I'm going to be left with 2 cubed, which is, so 2 cubed is 8. X to the 5 cubed is x to the 15. 5 cubed is, so that's going to be 25 times 5, 125. Y to the 6. Now, we then ask ourselves, can we simplify? And I don't think we can. I don't think, no, nothing goes into both 8 and 125. Okay. Next one, guys. This one says evaluate. The first 3 questions said simplify. So when it says evaluate, you're going to end up with a number. Okay. So this says 5 to the negative 2. How can I rewrite that? Yep.
1 over 5 squared.
Yeah, 1 over 5 squared. Because if I wanted to, I could have put the 5 to the negative 2 over 1, right? And then move the 5 to the negative 2 to the bottom of the fraction, changing the sign of the power. So guys, this then just equals 1 over 25. And that's good enough. Okay. Now, this next one. There's multiple ways to attack this one. There's a short way, there's a long way. What's the short way? Yep. Yep. Flip the fraction and then change the sign of the power. Because really what we did, guys, is we distributed the negative 2 through, then moved the bottom of the fraction up, made it 3 to the positive 2. Move 2 to the negative 2 down, blah, blah, blah. So anyway, this is the shortcut. Now, gentlemen, I need to distribute that 2 through, so that's 9 over 4. I have to distribute the squared through. I have to square the 3 and the 2. And that just equals, what's that? 2 and a quarter? 2 and a quarter. Okay. Now, I don't want to beat a dead horse, but what I could have done with this is said that that equaled 2 and then said okay, so you could have done it that way. Yes? Yeah, probably. Yeah, I can't see why not. Okay. So now, guys, we've got, those were the simple ones. Those were applying each of the laws at a basic level. Now the next 3 are going to combine laws. And there's going to be different ways to attack these. So for these next question, guys, sometimes there's going to be different ways to attack these, but there's only one correct answer. So with this first one, guys, what I'm going to do is I am going to combine the tops. So guys, what I'm going to do is I'm going to look after this. Okay? So the first thing I'm going to do is I'm going to simplify the top. Okay, so I'm going to take care of the top. So my bottom's going to stay the same as x to the 2y. Now my top is going to become what? Well, guys, my base is going to stay x. And then how am I going to have to write the index? What am I doing to the indexes here? Yep. Well, when I'm just looking at the tops, I'm adding them because I have x to the 4y times y to the y plus 1. So I have to add their indexes. So the index is now going to be 4y plus y plus 1. Okay? Now, guys, I know this is kind of ridiculous, but it's just practicing. Yep?
You just put 5y?
Yep, you could. I'm just going to do that in this step. Guys, you could have skipped that step and went straight to 5y plus 1 over x to the 2y. Now, guys, in this next step, what are we doing to the indices? Subtracting them. So, again, guys, you could skip this step, but I'm going to have x to the 5y plus 1 minus 2y, which simplifies to x to the 3y plus 1. Because if I have 5y and I take 2y's away, I have 3y's remaining. Okay. Now, B. Again, guys, there are multiple ways to attack this. I look at the 16 and the 4 and the 8. There's a common factor there. I could take 4 out right now. But I'm not going to. You could do that. I just don't want, I think it's going to be too messy with all the cancels and stuff. So what I'm going to do again, and guys, there's different ways to attack this. There's no right or wrong way. I'm going to take care of the top first. If you want to attack it a different way, that's fine, but there's only one answer. Now, the disadvantage of this way, guys, is I'm going to be working with some bigger numbers. So 16 times 4 is 64. Okay, then x to the 5 times x to the 4 is x to the 9. Okay, and then y times y to the 3 is y to the 4, and that is all over 8xy. Okay. Now, I like to show canceling. You don't have to show canceling. You could just go, 8 goes into 64 8 times. And then just write 8 down if you want. But I'm going to show canceling. 8 goes into 64 8 times. There's a 1 with the x. The 1 is smaller than a 9. So this x term on the bottom is going to go, and it's going to change that 9 to an 8. It was 64. Okay. That y is y to the 1. I take the 1 from that, from the 3, and that becomes y to the 3. So this simplifies to 8, x to the 8, y to the 3. Now guys, that's the only answer you can have. You could have gotten there a different way, but that's the only answer you can have. Okay, now the next one, guys,
So as you go from 69 on the top,
it's 64.
it looks like a 9.
Yeah, well, it's not. Alrighty, guys. Boys, last one. Now, this one's important because you guys might not remember this from last year. Now, guys, what I need to do with a question like this is, well, listen. You can evaluate these as numbers, but it's easier if you can get like bases. Okay, so the first thing I'm going to do is I am going to flip. I'm going to get all positive indices first. Then what I'm going to do is I'm going to break up some of these bases because I want to have bases the same. So here's what I mean. So the first thing I'm going to do is I'm going to make all these positive indices. So this 3 to the negative 3 comes down and becomes 3 cubed. That y to the negative 4 goes up and becomes 9 to the negative 4 goes to the top and it becomes y to the positive 4. Okay? This 6 to the 4 stays because it's already a positive index. This 12 to the negative 3 goes down and becomes 12 to the positive 3. This 2 to the negative 2 goes to the top and becomes 2 squared. Now, right, you could put that in your calculator right now. But you might get this on a non-calculator test. And here's what you would do. I can rewrite 9 as base 3. I can rewrite 9 as 3 to the 3 squared. Okay, so this is 3 squared to the 4. Okay. I can rewrite 6 as what? 2 times 3. All to the 4. I can rewrite 12 as 4 times 3. But I don't want 4. Because I don't have a base 4, do I? 4 is 2 squared. So 12 is actually 2 squared times 3. And I got to raise all that to the power of 3. Okay? Now, trust me, guys. This will work out to this will simplify quite well without having to go to your calculator. Okay. Now, guys, what does 3 squared to the 4 become? 3 to the 8. 2 to the 4. 3 to the 4 times 2 squared. Okay, did you see how I distributed the 4 from 2 times 3, the index to both the 2 and the 3? Okay. This stays 3 cubed. I need to distribute this cube to both the 2 squared and the 3. So that's going to be 2 to the 6, 3 to the 3. I'm not adding them, I'm multiplying them. Now, guys, what I'm going to do is I'm going to simplify the top and I'm going to simplify the bottom. Okay. 3 to the 8 times 3 to the 4 is 3 to the 12. 2 to the 4 times 2 to the 2 is 2 to the 6. 3 to the 3 times 3 to the 3 is 3 to the 6. Oh, shoot, what happens to my 2 to the 6s? Pow! Pow! And that just becomes 3 to the 6. Okay?
720.
What is it?
729.
729, like everyone knows. Yeah, listen, there's tons of ways to do this. Now, this way avoids you having to even touch your calculator.
I did 2 steps then.
Now, did you get the exact same answer? Okay, so, yeah, guys, there's different ways to do this. Did you just get, like, numbers, for, like big numbers? Or?
I just went straight from turning positive to
With bases of 12 and... Okay, listen. Okay, listen. Luca, I want you to stay with me right now. I don't want you doing it that way for this. I want you knowing that you guys, the big thing here to know is to help simplify, you can change things. So I can change 9, 2, 3 squared. I can break 6 up into 2 times 3 because I want to have like bases. Okay? Now I don't want you going and evaluating this because this might be on a non-calculator test. And you don't want to, probably, and you don't want to have to sit there and try to evaluate those numbers on a non-calculator test. Guys, we didn't have to touch a calculator to get to 3q, to 3 to the 6. Okay, now there might be different ways to do it, but this is how I've shown you to do it. If you can do it another way without evaluating to big numbers, I'm happy. Yes?
So with that 3 to 6, would you still have to evaluate that?
Well, listen, it might just say simplify. It did say simplify here. Expressing as positive indices. Yeah. Okay, that's it. So boys, hopefully you're feeling pretty comfortable with these because this is revision. Okay, so good luck with the homework lessons. Exercise.